So, good afternoon. My name is Filomena Barreiro. My home institution is the Polytechnic Institute of Bragança and the Laboratory of Separation and Reaction Engineering in Portugal. And I'm going to present the work entitled Learning Guides, Tools to Mediate Students' Learning. So, before starting, I will put this work in context. The work to be presented here was developed during an in-service training actions for teachers organized by Polytechnic Institute of Bragança in partnership with the training center associated with the Bragança School Associations. The focus of the training was experimental work in chemistry supported by the use of digital resources. So the training was organized in the context of the Chemistry All-Around Network project, and our objective was to involve teachers in the testing of digital resources and in a systematic way. For that, we have used the methodology based on the exploitation of a learning guide. So the in-service training was organized in 4 phases. The first step is to provide to the teachers some concepts for preparing and using the learning guides. The second one, the teachers have to choose a digital resource, then they have to elaborate a learning guide, and then they go to the schools and they test this learning guide with students. Some numbers of this in-service training. We have involved 14 teachers and around 120 students, and they have tested in the global 7 different digital resources: acid-base titration, electrochemical series, periodic table of elements, and other 3 resources from the path. That really is one of the resources that our teachers mostly used, mainly because they think it's it's attractive, and also because they can use it offline. They can download it and be not dependent from internet. So my presentation will be organized as follows. First, I will give some insights how to prepare a learning guide, what is a learning guide, why using a learning guide. Then I will present a case study done by one of our teachers, and then I will present some results analysis. So, what is a learning guide? A learning guide can be described as an ideation tool to created to support software exploitation and guide students during their learning process, helping them to organize unstructured knowledge in unstructured knowledge. A learning guide is structured in 3 main parts. The first one is challenge tasks, guidelines and questions are put to students as a challenge. Then testing, the phase of testing, laboratory activities, whenever it is possible, laboratory activities must be combined with the digital resource. And the last phase is entitled Knowing More. We intended with this to stimulate students to apply the knowledge, particularly in everyday situations, and thus attributing meaning to and usefulness to the science knowledge they have acquired. So this is a structure of the dynamics that between the teachers and students, and the teacher has to act in order to give autonomy to students, to stimulate ownership and give the opportunity to students to have an independent opinion about the work is developing. In that way, the students will use computers and educational softwares. They will interact with scientific models by changing data and variables, engaging in the exploitation of the physical situation, persisting in performing the test, showing initiative, taking control of their actions by making proposals, formulating new questions, by managing to involve other students, that is very important, involve other students in task accomplishment and the exploitation of the situation. So, proceeding with the presentation of a case study, we here have chosen this activity, radioactivity, beta decay, alpha decay, and radioactive dating. In this case, it is an activity where experimental does not apply and where microscopic level is important. So, the resource was chosen from the Portugal path, and they have used three main resources. So here I would like to give some insights of the guide. The first part of the guide is to define the objectives. In this case, the objectives were to understand the concept of radioactivity, identify radioactive isotopes, schematically represent the radioactive decay of some nuclides, determining the period of decay from the half-life time, and apply this knowledge to the dating of objects with hundreds and thousands of years. So here I have the learning guide. So the first part is the definition of the objectives, and then second part is the experience and answer the questions that are put, as I said, as challenges. And we have a main question that is put like a challenge, and then the student has several tasks. And at the end, we intend that the student know how to answer this challenge. And the last part, it will be the stimulate students to go further and apply the knowledge he acquired in the real life situations. So, proceeding, the testing of this resource was done by a teacher from Escola Secundária Abate Bassal in Bragança, and it was, she works in a secondary school, and the students were from the 12th grade, and the curricular unit was the chemistry discipline, that in fact in Portugal now is an elective subject, and the students' population was 17 students. So the strategy used was the following. The digital resource was explored by the students following the instructions described in the learning guide. Students were divided in groups of 2 elements per computer. Here it is very important because it's important to have two students because they have shared opinions. Okay, not only a student with one computer. So they have discussed the learning guide. They have studied it together, but at the end they have to produce their own report, individual report. Analyzing the results were analyzed based on 2 tests, one pre-test and a post-testing. In fact, the same questions were posed before and after the activity. And some major evidences conclusions were that the highest classification in the pre-test was 60%, while in the post-test was 96%. The lowest grade in the pre-test was 30%, while in the post-test was 58%. On the pre-test, the average grade of the class was negative. Only 7 students were able to score higher than 50%. And on the post-test, 12 students scored markers higher than 70%. And the class average increases to 80.9%. And the normalized gain was around 0.64. So, some main conclusions. The digital resources constitute powerful tools available for scientific exploitation, that must be mediated by the teacher and learning guides to propitiate a significant learning. And if possible, whenever it is possible, it is interesting to combine the interactive digital tools with laboratory work in order to improve classroom environment and the quality of student learning. So, thank you for your attention.